Hi students, welcome to HSC Earth and Environmental Science and Module 7, Climate Science. This is video number 19 and we're going to be looking at changing glaciers and ice. So the learning intention linked to this video is to investigate flow-on effects of changes to climate, including but not limited to changes in glaciers, sea ice and ice sheets. One of the most devastating kinds of changes that has been linked to all of the changes associated with climate change is the collapse in components of the cryosphere. So we've previously looked at the cryosphere and thought about the snow and ice that covers the planet, and the fact that we are losing quite significant mass of snow and ice each year. What we want to do in this video is to see if we can identify some of the specific changes that have been occurring, see how many of those we can link directly to climate change, and see what some of the implications are for some of the changes that have been occurring. So the first thing we know is that when we've been measuring glaciation, we've been realizing that our glaciers have been retreating now for some considerable period of time, particularly over the last 100 years. The fact that we've now got a lot of satellites that we've placed into orbit around the planet means we've got a lot of opportunities to be able to look down on our planet and to actually see some of the visible changes that we can identify from those sorts of devices. We know that sea ice is reducing on a long-term trend in both the North and the South Poles. And those are two different types of environments. The Arctic is basically a sea surrounded by land. In the Antarctic, we've got land surrounded by seas. But in both cases, we've got some levels of reduction, although some of the reductions seem to be more significant in the north than they are in the south. But we'll have a little bit of a look at that through this video and also in class. Measurements of the ice sheets in Antarctica show some ice volume loss, while the Greenland ice sheet has been shown to be thinning exponentially. And it's probably the one that I'll spend a little bit of time talking on because there's been some quite significant changes in the Greenland ice sheets. One of the problems is obviously icebergs that are sitting in the ocean are primarily underneath the ocean. So therefore, when they melt, they're not going to add a huge volume to the sea level and therefore cause subsequent sea level rises. Now, the only exceptions to that are if they are incredibly large, because obviously then even a small portion above is still going to be significant, or if they are on land and they are going to run the meltwaters that are created from the melting of the ice then runs into the ocean, and then of course you are going to be adding more volume to the oceans. So there's a couple of links there between what's actually happening in our cryosphere and how that might be leading to changes in the oceans, especially associated with both meltwaters and increased temperatures. Now, interestingly enough, just because we've got changes in the snow lines does not necessarily directly correlate with climate change, and probably one of the most compelling sets of photos that was used certainly in the Inconvenient Truth movie was these images of Mount Kilimanjaro, and snow cover is synonymous with Mount Kilimanjaro. These have melted more than 80% since 1912, and the difference is quite stark when you look at these pairs of pictures. Now, it's probably fair to say that the melting of the Kilimanjaro snow is not necessarily as closely correlated to climate change as it is to certain other influences that may be associated with the mountain itself, its location, any other geological activity that might be occurring in the area. There's a few little complex things that maybe contribute to that. If it was an isolated case, then you'd probably say, okay, well, maybe this link between melting ice and climate change isn't strong. But the reality is that we see retreats in glaciers all around the globe. We get the Himalayan glacier group are retreating at such a rate that we think that we might not have any left by about 2035. The Arctic sea ice has thinned by 10% over the last 30 years. Greenland's ice sheets are shrinking. And I guess one of the things that's most important here, and that does suggest that there is a link between what's happening in the climate and what's happening to the ice and the snow in particular, is we're actually seeing some slight changes in seasonality. And when you see changes in the seasons, even small ones like this, you're starting to get an appreciation for exactly what the problem is in terms of some of these changes in the distribution of snow and ice around the planet. Some of the things that have been noticed in the northern hemisphere are that the spring ice breakup is occurring 9 days earlier, so the warming is happening 9 days earlier, and the autumn freeze is happening 10 days later. So we're shortening the winter and we are lengthening the summer, and as a result of that, the ice doesn't have as much time to form, and once it has formed, it's being heated up more earlier, more quickly, and so therefore more of it is melting. I guess of more significance is the thawing permafrost. Now, permafrost is basically permanent ice. So it's parts of the ground where it's so cold that any of the water in the ground freezes and becomes ice. And this is what we refer to as permafrost. So there's certain places near the poles where the permafrost can be found. But even in these types of environments, we're starting to realize that some of this permafrost is thawing. And in cases where it is, we're getting ground subsidence of sometimes greater than 4.6 meters. So real drops in the ground surface as a result of these solid lumps of ice thawing, turning back into liquid water and causing a slumping of the ground. These are quite significant impacts because it's suggestive of changes of temperature, changes of climate conditions over significant periods of time. When you move from the Arctic to Peru, from Switzerland through to Indonesia, we're seeing massive ice fields, huge glaciers, and also sea ice disappearing. These are significant concerns, and these are happening at a global scale. And as we've talked about previously, the average changes don't even themselves out all over the planet. There are certain places where we see significant changes, and they are having a potentially permanent effect, particularly in areas where we once had abundant snow and ice. So finally, just to have a quick look at Greenland, and Greenland's an interesting one because the significant meltwaters associated with the reduction of glaciation on Greenland are actually believed to be one of the most significant contributors to rising sea levels. The ice sheets in Antarctica and Greenland contain 99% of the fresh water that's actually locked up in ice. The Antarctic ice sheet extends almost 14 million square kilometres, containing 30 million cubic kilometres of ice. In Greenland, the ice sheet is not as big, and the concern with the Greenland ice sheet is that we have a significant contribution to rising sea levels. The change in temperature, which we know with water will cause an expansion, is not believed to be quite as significant at this stage. It certainly could be in the future, but not as significant in this stage as the amount of fresh water that is entering the oceans as a result of some of these declines in ice sheets. At the higher elevations, increases in the winter snow accumulation may partly offset the melt. So when we go up a mountain, if it stays cool and you get snow, you get precipitation in the form of snow that's falling on, that can accumulate snow and ice on those high mountain peaks, for examples. But one of the problems that we have is that the rate is currently insufficient. So whilst we might hope that snowfalls are going to continue and they're going to replace some of these meltwaters that are taking the snow away, at the moment we're not getting enough snow to replace the amount that's lost. And the consequence of that over time is that we're going to have less and less. So, in other words, our cryosphere is shrinking and is virtually on the edge of collapse. And it's one of those things that can't be undone. And we might find that we're going to get to a point where it becomes too late to reverse these effects. It becomes too late to try and rebuild things that we've lost. The cryosphere is one of the important areas that we've had a look at in several other components of this course, and particularly in this module. And it's one of the things that we'll have a look at in terms of some of the data back in the classroom. Thanks for watching.